River flooding is one of the most problematic disasters for the human population. It affects nearly everyone on the planet. Not only are its impacts widespread throughout the globe, it also causes billions of dollars in damages every year and causes loss of life. And this right here is just one example of a river flood. We're down here at the Lemoyne River that goes through the north side of Macomb. And normally the river channel's way out there, where those trees are supposed to be. The river has spilled out of its channel and has flooded this vast floodplain. The waters go way back there. There's substantial evidence that river floods, not only in the United States, but worldwide, are becoming more frequent and more severe. But why exactly? There are several factors that can influence the frequency and the severity of a river flood. And some of these factors are human caused, such as building levees and building in the floodplain. But I think one of the biggest reasons why river flooding has become so bad is that we have a changing climate. Our climate is warming. And with the warming climate comes more precipitation on a widespread scale. So here we are, we're going to look at the effect of worsening river floods on human society, as well as look at the reasons why this occurs. So before we get into our topic, we're going to take a look at some of the background. So we'll start with, what is a river flood? So a river flood is a natural overflow of a river's channel onto a floodplain. And a floodplain is the area that surrounds the river. It's a flat landscape that surrounds the river. So water that's coming into this river channel is too great for the channel to handle. And so what happens is that the water comes in, it exceeds the capacity of the riverbank, and so that excessive water starts flooding the surrounding landscape. And this here is a good diagram of a river channel and its surrounding floodplain. So there in the middle of the image, you can see that is what a normal river channel is. It's usually pretty narrow, and it has water consistently flowing through that channel. And in normal conditions, the water is less than the maximum capacity of the channel, and so the water stays within the banks. However, if heavy precipitation comes along, then the amount of water coming through the channel increases. And if it increases beyond the capacity, it'll flood the surrounding landscape. And so from the surrounding land up into that dashed line you see, which is called the base flood elevation, that is the area around the river that is anticipated to flood on a consistent basis. That is your floodplain right there. And then the flood fringe, you can see, which is beyond the base flood elevation, that is areas that would normally not flood, but they can flood in the most extreme circumstances. That is the absolute far edges of the floodplain, and it would take a really great flood to reach the fringes there. So that is the basic cross section of what a floodplain looks like. Here's a mapped example of what a floodplain looks like. This is my local community of Pontiac, Illinois. Now we have a river that cuts right through the middle of town. It's called the Vermilion. And because we have a river cutting through the middle of town, large sections of our city are sitting on this floodplain. And so those orange and those blue and orange colors and the dashed colors there, that is your floodplain. The dashed area is called a floodway. Those are areas that have been strategically left undeveloped to allow a naturally occurring floodwaters to expand outward without affecting most amount of structures. The areas in solid blue, that is our 1 in 100 year floodplain. So that is an area that is expected to be inundated by the Vermilion River once every 100 years, based off of historical data. And the orange area is the 1 in 500 year floodplain. That would be our flood fringe, basically. That is, in the most extreme cases, how far out the water would be expected to go. Now, we kind of talked a little bit about how a river floods, but we'll go into a little bit more detail here. So like I said, a river is normally flowing at a certain capacity. There's a certain amount of water that is going through the channel at any given time. If heavy precipitation falls over the drainage basin, that water is funneled down the river. And because now you have a higher capacity of water flowing through this narrow channel, the water wants to expand outward. But in the channel, the land is able to hold it in, so the river will increase its height. However, once it reaches that maximum capacity, then the water actually begins pushing outward onto the surrounding landscape. And that is exactly how we get a river flood anywhere. Here's an example or a good diagram of what a river drainage basin is. So all rivers have a source. That source can be the convergence of two other rivers, or it could be just a collection of smaller streams and creeks. Whatever the source is, that is the beginning of the watershed, which is the drainage basin, basically. So a river will start at its source, and as a river flows towards its mouth, or the point where it starts emptying into a different body of water, it will collect these smaller streams called tributaries. Tributaries can be other smaller rivers, or they can be creeks, they can be streams, they can be ditches. These are all called tributaries. And these tributaries add water to the main channel, so the channel will typically widen as it gets closer to its emptying point. And then the mouth of the river is its emptying point. It empties into a larger body of water. So any precipitation that falls over those tributaries, that's the watershed. So anywhere where the rain is, or heavy precipitation or snow melt or whatever is happening, the water is collected and it is carried down the main part of the river. Now, what do rivers do to civilization? Well, rivers are located all around the globe, and so river floods can affect anyone on the planet. It is a leading cause of damage every single year. Floods cause more damage than any other natural disaster every year on average. Not only do we have serious property damage, but there's also loss of life sometimes. And that leads to destruction of some urbanized areas in the floodplains. Unfortunately, there are several big developed areas that are in these floodplains. And the reason behind that is because floodplains are very fertile. You can you grow your crops, and rivers are an excellent source for travel. And so that is why we tend to see our large cities develop in these areas, despite the hazard of being flooded. There's no doubt that our climate is warming. Global temperatures have been climbing steadily now for the past several decades, especially from the 1970s onward. And it is expected to continue. There's not really any reason that our global temperatures are just going to stop warming up, at least in the near future. You can see here by this map on the side Basically from the 40s and 50s onward, we have been steadily increasing. You have your annual variations in global temperature, but overall the trend continues to be further and further higher than the long-term average. And the long-term average is that zero line you see right there. So we are now, on average, here in the 2000s and beyond, we are 1 degree Fahrenheit above the long-term global temperature average, which is huge. That's a huge amount of warming. We have some problems with this. One common misconception about global warming is that people expect there to be just a constant period of warmth and heat. But that is not actually what global warming does. We actually now see more extremes with the weather pattern. That means we see more extreme heat in the summer, and we see more extreme cold in the winters. We have these bigger extremes in our local weather patterns, our near-term weather patterns. But because we are warming up on average, warmer air has a higher potential to evaporate moisture. And because we're getting higher evaporation, we're getting more precipitation. So precipitation is becoming a lot more extreme. And this leads to more impacts on the human population. And that does include river flooding. This is a map to confirm that we are seeing more extreme precipitation. This is a map by year. It shows the percent of land area in the United States that is experiencing above normal precipitation from year to year. You can see that, especially since the 70s and 80s, that we have been on an overall increase, essentially, in extreme precipitation. You can see there's still a lot of variability from year to year, but overall, ever since the 80s and especially in the 90s onward, you can see the percent of land area in the United States. We've had several years in a row, really, that over 20% of the United States has experienced extreme precipitation. So there is clear evidence that as our climate is warming, our precipitation is getting worse and worse. There's also strong evidence that river floods are becoming more frequent and more severe, and this is pretty much expected. We're getting more precipitation, so our floods are going to become more frequent. So in any floodplain, you have a 1 in 100 year flood or 1 in 500 year flood, like we talked about. Our floods that are expected to reoccur every 100 years are now happening every few years or every several years in some areas. And our events that are supposed to reoccur every 500 years now seem to be happening every decade or so for some areas. So that is a clear indication that our river floods are increasing as our global temperatures are rising. And now we're going to take a look at a river that is arguably one of the most heavily impacted by these shifts in our long-term weather patterns. This is the Red River, and it's not to be confused with the Red River that flows through the Southern Plains. This is the Red River of the North. This river begins near the city of Wahpeton, North Dakota. It's in far southeastern North Dakota to the south of Fargo. It forms at the confluence of two rivers, which is called the Boy-to-Soy River and the Otter Tail Rivers. They come together and form the Red. And so it flows north and forms the border. You can see on the map here on the side, it forms a border between Minnesota and North Dakota. And it continues to flow north into southern Manitoba and Canada. And then it empties north of Winnipeg into Lake Winnipeg. Now the Red River was formed after the last glacial period stopped. So after the glaciers retreated, they left behind a very large glacial lake called Agassiz, and it covered a large area of the north central United States. And so this lake drained away less than 10,000 years ago, so fairly recent in our geologic history. And this river, being so young, has not had time to cut a big floodplain. And so what happens is that this ancient lake bed that we have in this area now is the floodplain for the Red River. So it's very vast. So when this river floods, it expands miles and miles and miles. The Red River is very prone to flooding. It's had many floods in the past and will have many more to come in the future. However, in the last few decades, floods have become much more frequent, especially since 1980. We've now had 1 in 100 year events happening several times since then. And there's a list of years that we've had these floods that have reached the 1 in 100 year floodplain or beyond. 96 was one, and then just the next year we had an even more severe one in 1997. Then we had one in 06, and then 3 years in a row, 2009, 2010, and 2011. I wanted to focus here on the 1997 flood because it's particularly severe. It is one of the worst on record for this area. In particular, this devastated the city of Grand Forks, North Dakota, which Grand Forks is a city just on the other side, or it's right on the border of Minnesota. It's a city of over 50,000 people. And in 1997, they had a flood, and it broke through their temporary flood protection. They had put up these sandbag dikes to try to hold the water back from their neighborhoods. And so the dikes were overtopped, and about 90% of this community, of this city of about 50,000 people, was evacuated. And after the waters had stopped rising, by the time they had reached their peak, 83% of community homes in Grand Forks were damaged or destroyed. That's an inconceivably high number, especially for such a fairly large city like that. And just to kind of give you a perspective of how bad this flood was, the river crested over 20 feet over the flood stage. Now the flood stage is 28 feet in Grand Forks, and it crested at 54.35 feet. And here's just one image that you can find of the flooding in this area. This just shows you how widespread the water is. You can see it's really only the western sections of that town that remain dry. Everywhere else, you can just see, the farthest you can see is just inundated with water. This here is a graph or a scatter plot that shows the frequency of flooding along the Red River. This is actually at the Fargo, North Dakota gauge. This is a city that is south of Grand Forks, but still regularly experiences flooding. And this graph clearly shows the frequency of floods increasing and increasing. So prior to 1950, we did have a few floods, and flooding conditions basically start developing once it gets around 5,000 on this side. That's 5,000 cubic feet per second. So you can see that before 1950, it did flood several times, but for the most part, a lot of these floods were not particularly severe. We had one this is probably 1979, where the flow was 25,000 cubic feet per second, so there's a severe flood there. But there's really only a few that are particularly bad. The really bad ones are the ones that are 15,000 and above. We had one in the 40s. Yeah, 40s. And then one here in the 50s as well. But you can see, look how many of these circles are above 15,000 feet, or 15,000 cubic feet per second as you get beyond the 60s and 70s. So it's happened several times since then. And then particularly, we've had a major uptick in the severe flood frequency. You can see there's the 1997 peak flow at Fargo. There's 2010 right there. There on the right. The flood of record for Fargo is actually in 2009, where it was nearly 30,000 cubic feet per second as the peak flow there. But this graph, this scatter plot, can clearly show the correlation between our rising global temperatures and our heavier precipitation and the frequency and severity of the floods. It's just all coming together here. Now we'll talk about the influence on society for these floods. We're having more severe, more frequent floods, so now we're spending more money on these flood disasters. We're still developing on these floodplains despite our changing climate and weather. So what does society do? We find ways to kind of mitigate the flood hazard, and we'll talk about why some of these methods are just not so great. We're building up flood walls. These are usually concrete structures that'll hold water back. We're building levees, which do the same thing out of earthen materials. They're usually made out of dirt and clay. And we're even building diversion channels. These are man-made streams or channels where floodwaters can flow around a city, and so the waters usually will not reach these urban areas. However, if any one of these fail or break, it causes a lot more damage than what would happen with a natural flood. And going back to our 97 flood disaster, new levees were built shortly after. Grand Forks spent $409 million on a new levee system. And that image there in the top left corner, that's a picture of a portion of their levee. So basically what it is it's like a hill pretty much. It now protects the city up to a 60-foot flood now. That's even higher than it reached in 97. And they took developments out of the 100-year floodplain to prevent future flooding in those residential areas that were taken under. So we'll talk about some of the problems with these levees and these other flood walls. These levees are placed pretty much right along the river for the most part. And so what they do is they make the elevation of the land around the river higher than what it was before. So instead of that water being able to push out onto the floodplain like it would naturally, it holds the water back in and it squeezes the river channel. So now future floods are running even higher for the same amount of water. So say your river floods some year and there's no levee there. There's a certain height of that flood of the river. Let's say this exact same amount of water passes through the river channel now that a levee has been built. Now your river ends up higher for that same amount of water that came through some years ago. And so that's a problem, especially with our climate changing. If we're getting warmer, we're getting more precipitation. So more water is entering these river systems. And so not only are your floods more severe just from putting up the levee, now they're more severe from a higher water content going through the channel. So what happens is that these levees that are being built will eventually be overtopped, and so you get catastrophic damage for any areas that have developed in the floodplain. So what they do is they build the levees even higher, and they put up flood walls, and so eventually, that'll make the river go even higher, and the cycle just continues on and on and on. And like I said, if the levee ever breaks, even more destruction would occur because the water comes rushing into the city or whatever developed area it is. It comes rushing into the city, and it causes catastrophic damage versus what would happen if the water were to naturally expand into that area. I want to thank you for tuning into my presentation.